Okay. Alright, I decided to wait until Thursday to go through that box. So I just want to show you guys what we have, and I'm going to have to try to figure out where to put stuff. I might not... it's still kind of up in... We're still trying to figure out the whole thing of, when, if possible, that we're going to be able to get into a trailer in town so we're closer to work right now. These without having a vehicle. As far as the property goes, I don't care if I have a bike. One way or the other. But I will be right back because I have to answer a text real quick. Okay, sorry about that. I had to answer a text about the trailer in town. Trying to see if we can get something worked out. So, anyway. So, yeah, I'm gonna wait until Thursday because I don't want to have to worry about the time when I go through that stuff. So, anyway. So, our next one is called Why Does Personal Beekeeping Need a Scientific Approach? Why beekeeping needs the scientific method. Beekeeping, an art and science that for millennia has only improved due to the use of the scientific method. Every significant improvement in keeping bees has come from this process, yet, for some reason, there are a large number of beekeepers who refuse to accept science, research, and even the basic principles of the scientific method as a way to help improve their success in beekeeping. I'm not interested in getting into the argument about why those beekeepers have chosen to refute the science and data available to them to make small changes in their beekeeping philosophies and tools. This is all about how someone who is looking to find a way to improve their beekeeping success can use some simple processes to ensure growth in their skill set and ability, as well as new information to improve their chance of successful beekeeping. Yeah, I was up a little too late last night. That was my fault. I was going through some stuff on my phone and my new one. Anyway, basic scientific principles. One of the most famous examples of the scientific method is the story of Gregor Mendel and his pea plants. I'm just tired. In the mid-19th century, Mendel, a monk in what is now the Czech Republic, was curious to learn why offspring inherit certain traits from their parents but not others. He experimented on mice and honeybees before finally settling on pea plants as his preferred test subject. Mendel experimented with pea plant genetics for over a decade. Using the scientific method... Sorry, there's a truck backing up outside. All along, he had made an observation. Offspring inherit traits from their parents. He asked why those offspring inherit certain traits and not others. He made a guess that certain traits are more heritable than others. He tested his hypothesis and took thorough notes. Then he analyzed his results and was able to conclude which traits occur at what rates, which led him to conclude that some traits are dominant and will appear more often, while others are recessive and require a certain combination of genes in order to be expressed. Oh, man. Yeah, it's going to be one of those days when I'm tired because I did not get enough sleep. Get some more water in me. Through the years, this experiment has been the basis for countless other experiments. Many people have made their own observations and used Mendel's hypothesis to form their own hypotheses and experiments. The scientific method is a cycle. Each experiment will lead to another. In order to best understand how to make changes, we first need to understand the basics behind the scientific method in problem-based learning. Nothing in beekeeping is a cookie-cutter recipe quite yet, but often as beekeepers, that's what we do. We follow blindly based on what others are doing. Instead, we need to learn techniques and skills from other beekeepers, but also learn how to apply these correctly by leveraging the information and observations we are collecting. This is the only way we can solve the issues of colony collapse disorder on a small scale ourselves. I am by no means saying that what experienced beekeepers are telling you to do is incorrect or wrong, but it is your job as student and as steward of your colonies to take a critical approach to applying the knowledge that is being passed on to you. I am not staying up late tonight. I've noticed... Okay, I'll talk to you guys about that when I'm done with this. As you check on your bees, it is important to follow the steps of the scientific method. Number 1, observe. Make a note of something that you observe your bees doing and that you are curious about. This could be anything from which bars of comb your bees are using or for different purposes to the pitch of their buzzing. Number 2, ask a question. That does not mean asking the bees a question. They won't answer you that way. And if you're talking to bees and expecting answers, then I think you might want to get checked out. Ask why they may be acting the way they are. This may be the most important step in the entire process. Yes, I will probably talk to our bees, but I'm not going to expect them to answer me. If they start talking, I'm in trouble. You may observe something, but you won't get anywhere if you don't ask why what you are observing is happening. Where would we be, after all, if the aforementioned Mendel had not been curious about heritability? Number 3, do some research. Remember what I said, do your research. Read what others have said about your question. Try to find as many different sources as you can, and at least a couple of opposing arguments so that you can be as informed as possible. Sorry. I am tired. My fault, though. Number 4, make a guess. Using the knowledge you gained from your research, make an informed hypothesis as to why you think your bees are behaving this way. Number 5, test it and track it. Continue to pay close attention to their behavior over time and determine whether it supports your hypothesis. Keep careful notes so that you can compare each inspection. Number 6, analyze. Look through your notes and see how they compare from inspection to inspection. Do you notice any key patterns? How do your observations support or refute your hypothesis? I think that was 6, sorry. Yes, okay. Number 7, discuss and adjust. Discuss your findings with other beekeepers and see what they think. Perhaps they will have some ideas as to how to improve your experiment, or will begin to replicate it with their own bees. Adjust your hypothesis as necessary. Number 8, observe. Again, continue to observe your bees and taking notes. The more data you can collect, the better. The aggregate application of all of these small problem-solving endeavors will help to build a geographic map filled with analytics that will help the entire beekeeping community identify patterns and issues on a local level. Why the scientific method is important. Number 1, Wisconsin alone has 5 different ecoregions that can contain anywhere from a single biome to 12 biomes, all of which have a different ecosystem, weather, human density, farming density, etc. If you have a friend who keeps bees in one area of the state and you are located in another, something that works for them might be completely wrong for your bees. It is important to make your own observations and see what works for you. Number 2, by building a data-driven baseline, we can begin to adjust beekeeping practices in each of these biomes specifically for what is available. We can bring in more nutrition and plant diversity. We can understand if pesticides are doing anything. We can understand if the bee genetics are making a difference or not. Eventually, this can turn into a tool to drive policy or research to help the overall health of domestic and native pollinators alike. Number 3, multiply this effect across 50 states, 7 continents, etc. Number 4, now see the impact it has on other disciplines and sustainability endeavors when beekeepers set the standard. How to record your data. You may be thinking that this all sounds like an awful lot of work and a lot of time organizing and rereading notes. It doesn't necessarily have to be. Using a pre-made hive inspection form or software keeps your notes organized and consistent in both key players in practicing the scientific method effectively. I'm going to be getting a beekeeping journal. I think I already stated that or said that, and I'm going to actually look up. Maybe I can get I don't know, like a pad of inspection forms or something. I don't know. To help make hive-side data recording even simpler, Bee Pods will soon be launching a hive inspection app that will have easy-to-navigate inspection forms. We are hoping to launch the app within a few weeks, so be sure to check. Okay. Anyway, and that's from Bee Pods, so I'm probably going to check that up. But that was the end of that one. On why beekeeping needs the scientific method. So, there's that one. And again, I hope you guys are getting a lot of information out of this, and I hope it's useful and that you guys are willing to try it and just work on your own stuff. So, I will get this video up there and get ready for the next one. See you in a few minutes. Bye, guys.